Wrangling a star that's traveling at millions of miles per hour is a daunting task. Luckily, we've got a star right next to us that travels at a respectable 500,000 miles per hour around the center of the Milky Way. That's much faster than the fastest man-made object, the Parker Solar Probe, which, thanks to the Sun's gravity, has reached speeds of almost 290,000 miles per hour. And in 2025 will max out at 430,000 miles per hour. Earth is already being pulled along through the Milky Way by the Sun. But if we want to be in control of our own destiny, we need to build something capable of steering the Sun in a desired direction. One such hypothetical device is a Shkatov thruster. First proposed by Russian scientist Dr. Leonid Shkatov in 1987, a Shkatov thruster is a stellar engine that takes advantage of solar radiation to create propulsion. It's essentially an enormous concave mirror that reflects solar radiation and photons. That same radiation pressure keeps the thruster from being pulled into the Sun. Normally, the Sun emits radiation in all directions. But with the mirror there, radiation from one side is reflected back towards the Sun, creating thrust in one direction. A Shkatov thruster isn't the only kind of stellar engine that's been proposed. It's just the easiest to build. Another hypothetical stellar engine is a Dyson sphere, a megastructure that would encompass a star in order to capture its energy. But a Dyson sphere alone wouldn't function as a propulsion system. A healthy median is the Badescu Cathcart thruster, which would provide the propulsion of a Shkatov thruster while maintaining the energy-generating capabilities of a Dyson sphere. It would probably look like a Dyson sphere, but incorporate a giant mirror or mirrors. However, it would be a lot less stable than a Shkatov thruster. So if propulsion rather than energy production were the primary goal, you'd still be better off with a Shkatov thruster. Finally, there's the Kaplan thruster. Proposed by astronomer Matthew E. Kaplan, this thruster would use the Sun's mass as fuel, which would be slowly depleted to power the thruster's powerful jets of plasma and oxygen. While a Kaplan thruster would be the fastest stellar engine of all, it's also certainly the most complex and would eventually destroy the star. The idea that we could ever build a Shkatov thruster might sound far-fetched, but we already know everything we need to construct one. We've conducted a decent number of experiments involving solar propulsion over the years, even as early as Mariner 10 in the 1970s. So we know how solar radiation propulsion works, and we know exactly how to do it. In fact, LightSail 2, a crowd-funded spacecraft developed by nonprofit organization the Planetary Society, proved that solar sails were fit for purpose in 2019. The spacecraft is even a similar shape to what our eventual Shkatov thruster will be, only far smaller. The problem with solar sails is that they get less effective the further away from a star they are, which means that for all their benefits, they're not suited for deep space travel. But of course, if we're using our Shkatov thruster to take the Sun with us, we don't have to worry about this at all. And both small and giant solar sails have an advantage over regular rockets, namely, they don't need a fuel source. As long as the star it orbits is still producing solar radiation, we have an engine. And with our own Sun, it would last for billions of years. Of course, eventually the Sun will run out of hydrogen to fuse and die. Even before that, in about 1 billion years, it will heat up and destroy all life on Earth. But we can definitely travel quite far before that ever happens. Far enough to find a new star system and maybe build ourselves a new thruster on a longer-lived star. This lack of fuel makes the Shkatov thruster distinct from other types of interplanetary and interstellar propulsion, such as ion thrusters and warp drives, which both have limitations of their own which a solar sail doesn't share. Ion thrusters are slow, while warp drives remain theoretical, relying on the existence of suitable exotic matter which we have yet to discover. And of course, there's the enormous benefit that the Sun's gravitational pull will drag the Earth along with it. So we'd be taking our home planet with us wherever we went. Not to mention any other human colonies that would exist on Mars, Venus, Titan, or Europa by the time we're able to build a thruster. But like everything else in space travel, there are negatives that come with a Shkatov thruster as well. Namely, that in the solar system, we would have limited mobility. We would only be able to place the thruster at the poles of the Sun. If we placed it at the side of the Sun, we would either blast Earth with double the amount of solar radiation and light as it was reflected from the thruster's surface, or we would block out the Sun and completely freeze the planet. This means we'd only be able to move the Sun vertically in relation to Earth's orbit, which isn't great if our goal is to take the Sun in any direction we want. Fortunately, we're not limited to only using the Sun for a Shkadov thruster. We could also use another star. Then we have another problem, however. Other stars are very far away. So we would have to travel to those stars and then undertake the construction of a Shkadov thruster. This means we need other methods of propulsion, and we need to either be willing and able to ferry resources from the solar system, or we need to find a resource-rich star system and take advantage of what's already there. We would probably have to strip mine an entire planet, or multiple planets, to create a reflective surface big enough to create thrust. Suffice it to say, if building a Shkadov thruster in our own solar system is difficult, building in another system entirely could be impossible. The final problem with a Shkadov thruster is that they simply take a long time to build up momentum anywhere near what a star can already accomplish. So we wouldn't be speeding through the stars right away. So if it's so tricky with so many drawbacks, why build a Shkadov thruster at all? Well, the biggest reason a device like this might someday be necessary is if the solar system starts to head towards something dangerous. The Milky Way is full of rogue planets and even rogue black holes, celestial bodies in orbit around the galactic center rather than belonging to a star system. We'd be in even more danger by getting just a little too close to a supernova. These won't pose a threat to us in the foreseeable future, but it's always possible that one day we'll make a wrong turn, and the only way to save the entire solar system from destruction might be to seize control of it ourselves. The dance of the stars around the Milky Way will also become more chaotic in the distant future. In about 4.5 billion years, the Milky Way will collide with the Andromeda Galaxy. The chance of stellar collision is minute, but still, it could change the path of whatever solar system we're living in by then, leading to new hazards. Then again, maybe in our journey around the galaxy, we'll just spot something particularly interesting nearby and want to take a look. The other major reason Shkadov thrusters are useful is that they can eventually reach incredible speeds with, once again, absolutely no fuel. If we can steer a star wherever we choose, there's also the potential not only that we'll be closer to star systems with habitable worlds of their own, but also that we could pull in some of those rogue planets in a non-destructive way and maybe end up with new planets within the solar system. When combined with a Dyson sphere, Shkadov thrusters would put us in command of the stars themselves. The ability to pilot the stars would give humans unprecedented control over their own destiny, as well as the ability to change the very shape of the galaxy. And that's what would happen if we could move the stars.